You're listening to the Bare Metal Cyber Prepcast, created to help you succeed in your IT Fundamentals certification journey. Learn more at baremetalcyber.com, where additional prepcasts, books, and training materials await. Let's get started. In this episode, we explore two rapidly expanding categories of smart technology home automation systems and wearable devices. These technologies combine connectivity, automation, and data analysis to improve daily life. From voice-controlled lights to wristbands that track heart rate, these tools are reshaping how consumers interact with their environments and their health. As more users adopt these systems, IT professionals must be prepared to support, secure, and understand the roles these devices play. This topic is covered in Domain 2 of the ITF Plus exam under Computing and Internet of Things devices. Questions may ask you to identify a device based on its function, determine how it's used, or evaluate its network requirements. You may also see scenario-based questions involving security, data syncing, or user configuration. Understanding home automation and wearables supports real-world problem-solving and helps reinforce foundational IT concepts across several exam domains. Home automation refers to systems that control residential devices either automatically or remotely. These systems often include smart lighting, heating and cooling, locks, cameras, appliances, and more. They are designed to respond to user preferences, schedules, or sensor inputs. For example, a light might turn on at sunset, or a thermostat might adjust itself based on occupancy. Automation improves convenience and can also help optimize energy use. Common home automation devices include smart thermostats that learn your temperature preferences, light bulbs that adjust brightness based on time of day, smart locks that let users unlock doors remotely, and garage door systems that open when a user approaches. Devices like these can be controlled via smartphone apps or by integrating with smart assistants. Each one performs its own function, but can also work as part of a larger system. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. Home assistants like Amazon Alexa, Google Home, or Apple HomePod act as hubs for home automation. These voice-activated devices connect to other smart systems, allowing users to manage settings, activate scenes, and receive updates hands-free. With a simple voice command, users can dim lights, adjust temperature, play music, or check the weather. Assistants often integrate with calendars, reminders, and third-party services to extend their usefulness beyond basic commands. Connectivity is the backbone of any smart home system. Devices may use Wi-Fi, Bluetooth, Zigbee, or Z-Wave to communicate with each other and the Internet. These communication protocols allow automation routines to run smoothly, whether they're cloud-based or handled locally. A strong home network is essential. If Wi-Fi drops or signal strength is poor, devices may lose connection, automation may fail, and users may lose control of their systems. The benefits of home automation go beyond convenience. Automation systems can reduce energy consumption by turning off lights and appliances when they're not needed. They can enhance home security through surveillance cameras, motion sensors, and smart locks. Remote access also allows homeowners to monitor and adjust their settings while away, providing peace of mind. These systems continue to evolve, adding intelligence and customization through software updates and AI learning. However, security is a concern in smart home environments. Devices may be vulnerable if passwords are weak, software is outdated, or networks are not properly secured. Hackers may gain access to cameras, microphones, or door locks if systems are misconfigured. Privacy concerns also arise as devices collect data about user habits. Protecting these systems requires encryption, strong authentication, and awareness of who or what is allowed access. Wearable technology refers to devices worn on the body that gather data, display notifications, or enable communication. Examples include smartwatches, fitness trackers, and medical wearables. These devices often connect to smartphones to expand their features or to upload data for storage and analysis. Wearables represent a shift toward continuous personal computing, bringing technology closer to the user than ever before. Wearables offer a wide range of features. Most track steps, heart rate, and sleep cycles. Many display incoming calls, messages, and calendar alerts. More advanced models include GPS, temperature sensors, or cellular connectivity. These features support users in managing their health, staying organized, and staying connected, all from a lightweight device that fits on the wrist or body. Smart clothing and specialized wearables are expanding the category beyond wrist-based devices. These technologies embed sensors into fabric, shoes, or accessories to collect data in real time. In sports, smart clothing may monitor posture or muscle movement. In military and research settings, it may track environmental conditions or stress levels. While still emerging, smart clothing represents a growing frontier of wearable computing in niche and professional applications. Medical wearables are also gaining traction. Devices like glucose monitors, portable EKG sensors, or oxygen saturation monitors allow patients and doctors to track health in real time. These tools can alert care teams to changes before they become emergencies. For chronic condition management, they provide an ongoing stream of data that informs treatment. Some models transmit data automatically to a clinician's dashboard, bridging the gap between the patient and provider. Wearable connectivity typically relies on Bluetooth to pair with smartphones and sync data. Some advanced devices include Wi-Fi or LTE support to operate independently, allowing direct access to cloud services, alerts, or updates. Data may be stored locally for brief periods or uploaded to cloud accounts for long-term tracking and analysis. Syncing issues, app compatibility, and update failures are common support challenges with these devices. Different wearable platforms run different operating systems. Examples include Apple's Watch OS, Google's Wear OS, and Fitbit's proprietary OS. These systems support core features like step counting, notifications, and app integration. However, they do not offer the same multitasking ability as phones or desktops. Understanding their limitations is important when helping users set expectations or troubleshoot compatibility issues. Privacy and data protection are critical issues with wearables. Devices often store health and activity data, which can be sensitive. Users must manage app permissions carefully, especially when syncing to third-party services. Organizations handling wearable data must follow laws like HIPAA or GDPR, depending on location and context. Mismanagement of this data can lead to privacy violations or unauthorized data sharing. Just like other smart devices, wearables require software updates to remain secure and accurate. Updates fix bugs, patch vulnerabilities, and improve features. Most wearables are updated through companion apps on smartphones, which may prompt users or perform updates in the background. Technicians must be prepared to assist with update issues or educate users about update importance. Failure to apply updates may lead to degraded performance or exposure to security threats. The ITF Plus exam may include questions that describe wearable features and ask for identification. You might see a scenario involving step tracking or heart rate alerts and be asked to choose the correct device. Other questions may cover connectivity types, such as Bluetooth or LTE, or require identifying use cases like health monitoring or field communication. Recognizing how these devices function supports your ability to handle emerging technologies. Home automation and wearables both impact infrastructure and support roles. As more of these devices connect to networks, the demand on Wi-Fi, cloud access, and device management tools increases. Support teams must handle a greater variety of hardware, protocols, and user expectations. IT professionals may be asked to integrate wearables with enterprise health systems or ensure home automation devices are compliant with remote work policies. To summarize, Home automation and wearable devices are reshaping how users interact with technology at home, at work, and in motion. They expand the IT ecosystem by adding new sources of data, new control points, and new support requirements. While they bring convenience and innovation, they also demand attention to security, privacy, and network planning. Recognizing their functions, benefits, and challenges prepares you for the ITF Plus exam and a world of increasingly connected devices. Thanks for tuning in to the Bare Metal Cyber Prepcast, your trusted source for cybersecurity news and insights. Remember to subscribe at baremetalcyber.com so you never miss an update. And visit cyberauthor.me for best-selling cybersecurity books that equip you with expert knowledge. Until next time, stay secure and stay vigilant.